Welcome back everyone to another video here on the Unknown Code YouTube channel. Today we are taking a look at diagonal traverse, which is number 489. This is a little bit more difficult one. This is going to be a 2D array problem. And this problem states that given an m by m matrix mat, return an array of all the elements of the array in diagonal order. Now it's a little bit confusing and there is some tricks to this. So let's go ahead and hop down below, take a look at the examples, and we'll go ahead and do some other things. So for example number 1, we're going to have the matrix equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. And in this case, it really helps to actually see this as a matrix. So we can go ahead and say the first row is 1, 2, 3. The second row is 4, 5, 6. And the third row is 7, 8, 9. Our result is just going to be some array. And what we'll do is we'll start in the top left. So at 1, then we'll try to go up and to the left, but we don't have anything left. So then we go over. Then we'll add 2. Then we want to go down diagonally to 4. Then we're going to be stuck again. So now we want to go down again to 7. And then now we can go up diagonally to 5. Go up diagonally to 3. Now 3 was stuck, so we'll go down to 6. And after 6, we'll go down diagonally to 8. And then we need to go over to 9. So that is how we'd get our result output. Now let's go ahead and take a look at the next example. For the second example, we have a matrix array called mat equal to 1, 2, 3, 4. So again, if we go ahead and make this into a matrix, the first row would have 1 and 2, and the second row would have 3 and 4. So once again, we start at 1, so result of 0 would be 1. Then we try to go up, but there's nowhere else. Then we go over to the right to 2. We can't go anywhere, so we go diagonally down to 3. Then we go back to the right to 4. So that would be 1, 2, 3, 4. All right, so let's hop back up and take a look at our constraints. So the problem itself is say it's going to have an n by m matrix. So the first two constraints are saying that m is going to mat.length. M is going to equal the number of rows that we have, and n is going to equal the number of columns that we have. And those unfamiliar, our rows are going to go up and down. So starting at 0 here, and then our columns are going to go left to right, starting from 0 there. So it's going to 0 to 2 at the bottom, and then 0 to 2 at the top, or to the side here. So that's going to be our first set of constraints. Our next constraint says 1 is less than or equal to m is less than or equal to 10 to the 4. This means that the number of rows or columns is going to be between 1 and 1,000. So nothing too crazy there. The next one states that 1 is less than or equal to m times n is less than or equal to 10 to 1,000. This means that the total number of values inside the matrix is between 1 and 1,000. Cool. And finally, negative 10 to the 5 is less than or equal to matrix ij is less than or equal to 10 to the 5. This means that the values inside of the matrix are between negative 10,000 and 10,000. Again, nothing too crazy there. So just to reiterate, the goal of this problem is to start at the top left corner, basically index 0, 0, and snake your way all the way through the 2D indexes, inserting your element into a new array. Then whenever you reach one of the edges of the array, you must go ahead and change direction until we have completed everything. This problem is a little bit more complex than some of the previous problems that we've seen, and that will probably be the case for a lot of these problems as we dig a little bit deeper. But at the heart of this problem, we basically just need to keep track of a couple of different things, mainly which direction we're currently heading in the array and whether or not we've actually hit an edge. When we do hit an edge, we have to change the state of which direction we're moving and then continue on until we've used up all of the moves that it takes to consume that initial 2D array. So now let's go and take a look at the pseudocode and do a quick code walkthrough before solving this problem over on LeetCode. So for our pseudocode, we're going to start out by saying let the result array be a new array of length m times n. This is where we're going to store all of our values. Then we want to say while we have not iterated m times n times. After we've done n times, that's basically gone through the entire 2D array. So while we haven't, we want to say if we are heading in the northeast direction and we haven't hit the right or top edge, we want to go ahead and set the index of result to the index of the northeast value of the current in matrix. Okay, then if we are heading in the southwest direction and we haven't hit the bottom or left edge, we want to go ahead and set the next index of result to the southwest of the current value. Then if we've hit any edges, we need to go ahead and flip the direction against where we're heading. And then finally, once we have completed everything, we'll go ahead and return the result. It's a little bit complicated, but it's not too crazy. Let's go ahead and hop over and take a look at an example and then hop into LeetCode and actually solve this. So this example is going to be a little bit long. We're going to start out with an example of mat equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not sure I'm going to do this yet, but I do want to go ahead and visualize this. So I do want to write out this entire matrix. So I'm going to say 1, 2, 3 as the top row, then 4, 5, 6 as the middle, and 789 is the last. And just as a reminder, we're going to have the x direction going left to right, starting at 0, ending in 2. And then the y direction will go from 0 to 2 in this direction. And that should hopefully help us out as we're going through this. I'm going to try to update this matrix as we're going. I'm not sure how this is really going to work, but we are going to start our direction as northeast. And our x is going to start at a 0 because we want to start in the first index. Our y will start out as 0, and result will be a new array of 9. For I equal to 0, our x is obviously 0, our y is obviously 0, and our mat of yx, backwards unfortunately, is equal to 1. So we are currently at this index right here, 0, 0. So now our direction is also northeast. But this means that we have hit the top because we have hit the top of it. So we're first going to go ahead and set result of I equal to 1. Then since we hit the top, we want to swap directions. And we also want to say x plus plus to move to the right. So for I equal 1, our x is now equal to 1, our y is equal to 0, our mat of yx is equal to 2, and our direction is southwest. So now we are currently on this index. So we went from 1 to 2, and now we are going downwards. So now we want to go ahead and set result of I equal to 2, and we haven't hit the bottom or anything. So we're just going to go ahead and move southwest. And to move southwest, we're going to say y plus plus and x minus minus. Next, for I equal to 2, our x is equal to 0, our y will be equal to 1, our mat of yx is equal to 4, and our direction is southwest. So now we are currently on the 4, so we've gone downwards to 4. Obviously, we have hit the edge here. So what we'll go ahead and do is set result of I equal to 4. And now we have hit an edge, so we need to go ahead and swap directions. And in this case, we need to go straight down. So we're going to go ahead and say y plus plus. Now we can go to I equal to 3. Where x is still equal to 0, y will now equal to 2, our mat of yx is equal to 7, and our direction is now northeast. Now we're in index 0, 2, so we have gone straight down from 4 down to 7, and since we're moving in the northeast direction, we're not hitting any edges, so we just want to set result of I equal to 7, and since we haven't hit an edge, we just want to go ahead and continue in the northeast, which will mean saying y minus minus and x plus plus. Now for I equal to 4, our x is equal to 1, and our y is equal to 1, and our mat of y and x is equal to 5. Our direction is still northeast. So now we have gone from our 7 up to our 5. Since we're moving northeast, we haven't hit any edge. We're going to go ahead and set result of I equal to 5, and we're not an edge. So we'll continue northeast. So once again, we'll say y minus minus x plus plus, and I equal to 5. Our x is equal to 2, our y is equal to 0, and our mat of yx is equal to 3, and our direction is still northeast. Once again, we've gone from 5, we've gone diagonally up to 3. This time around, we are at the top edge, so we're going to go ahead and say first, we'll set the result of I equal to 3. Now we are at top edge, so we'll change direction, and we'll do that by saying y plus plus. Now I equal to 6, our x is still equal to 2, our y is equal to 1, and our mat of yx is equal to 6, and our direction is now southwest. Now what we've done is gone from 3, gone straight down to 6, and we're going in the southwest direction. So now, since we're going in southwest, we haven't hit any walls or anything, so we're just going to go ahead and say set result of I equal to 6, not at an edge. So just continue southwest, which we'll go ahead and do by saying y plus plus, x minus minus, for I equal to 7. Now x will equal to 1, y will equal 2, and mat of yx will equal 8. So now we've gone from 6 down to 8 like this. But we're at the bottom, so we'll have to deal with that. But once again, we're also still in the direction of southwest. We'll set result of I equal to 8. And now we hit an edge. So switch directions. And for that, we'll just say x plus plus. Now for I equal to 8, our x is equal to 2. Our y is equal to 2. And our mat of yx is equal to 9. Our direction is southwest. Now we have basically gone from our 8 straight over to the 9, which is going to be the last one. So once again, we'll go ahead and say set result of I equal to 9. And then if we wanted to, we would still probably swap sides. So we hit an edge, swap directions, except we have nowhere to go because we're done. So then we'll go ahead and return result, which equals to 1, 2, 4, 7, 5, 3, 6, 8, and 9, which should be correct. Cool. I'm not sure how this is going to be edited, but let's go ahead and hop back into LeetCode and take a look at how we can code this. So to start out, we're going to go ahead and set up a couple of values. So int m is equal to mat.length, and this comes straight from the constraints. And int n is equal to mat0.length. Then we're going to say int array is equal to a new array. And this is going to be m times n. we're going to need a Boolean flip. And this is going to equal to true. This is going to determine whether or not we need to swap directions. So we're going to say int x is equal to 0, y is equal to 0, and index is equal to 0. And finally, we know that the first index of the array is always going to be matrix 0, 0. So we're going to say array of index plus plus is equal to mat 0, 0. And then we can start our loop. So we'll say while index is less than m times n. This is how we know we've gone through all of our indexes inside the matrix. We'll say if flip. So if we have flipped, we'll say x plus plus. And we'll say while x is not equal to 0. So we haven't hit that one wall. And y is not equal to m minus 1. Again, we haven't hit that one wall. Then we're going to say if x is less than n. We're going to say array of index plus plus is equal to mat yx. Then outside of this if statement, we'll say x minus minus and y plus plus. And then outside of that while loop, we'll also say array of index plus plus is equal to mat of yx. And then we'll also say flip is equal to false, so we'll change directions. Then we'll say otherwise, if it's not flip, we'll say y plus plus. Then we'll say while y is not equal to 0 and x is not equal to n minus 1. So we haven't hit those edges once again. What we want to say is if y is less than m, we want to go ahead and say array of index plus plus is equal to mat yx. Then outside of this, let's make some space here. Outside of this, we'll say y minus minus, then x plus plus. Then outside that while loop, we'll go say array of index plus plus is equal to mat yx, and flip equal to true. Then finally, we'll go ahead outside of the outer while loop and return the array. Let me double check that I haven't typoed anything. Oh, I accidentally put a greater than instead of a less than sign here. Let's go ahead and submit again. There we go. It actually went through the loop that time. I got accepted earlier, but I wasn't recording my screen, unfortunately. But there we have it. There is a 1 millisecond solution, which will beat 100%. It also beats 82% of the memory complexity as well. So that's pretty good. If you guys did find some value in this or just enjoyed the video, please leave a like, comment, subscribe. Remember, I'm uploading videos like this literally every single week, multiple times a week. As always, my name is Ethan Encoder. Hope you guys have a great day, and I'll see you all in the next video.